Welcome back. Today we are going to be talking a bit more about how to graph polynomials, but we're going to talk about a few other things along with that. First thing I want to mention is that we're going to talk about a couple of special situations, including some other types of parabolas and everybody's favorite in mathematics, a little bit of vocab, all right? It's important that we talk about the terms that are going to be used to describe different polynomials because it helps us have a common understanding about the different places or points of interest or key features on any particular graph. All right, so without further ado, I'm going to use this first problem as a warm-up, okay? So we're in factored form because each one of these things in parentheses, those are factors, okay? And remember, our factors help us identify where our x-intercepts are. So if x plus 3 is 0, x equals -3, so -3, comma 0 is an x-intercept. And if x minus 5 equals 0, then 5, comma 0 is an x-intercept. So 1, 2, 3, 4, 5, 2, 3, -3. All right. Now, there's a couple of things we need to talk about in terms of a parabola specifically. So this guy's in factored form. Now, how do I know this is a parabola? Let me back up for a second. I know it's a parabola because this must have degree 2 because we have two factors, and so those two factors together mean we have a degree 2 polynomial. In other words, a parabola or a quadratic. Okay, when we have something like that, that means that the function has symmetry, okay? The point of symmetry is that axis of symmetry. And if we look, we want to find the place in the middle. So that's going to be at 1. It is always going to land in between the two x-intercepts. So x equals 1 is our axis of symmetry, okay? Now, I can figure out the maximum or minimum value by substituting that number into my equation. So I'm going to do that off to the side here. So 1 plus 3 times 1 minus 5. So that's going to give me 4 times -4. So it's going to give me -16. So that's going to be a minimum at y equals -16. So to make that fit in my graph, I'm not going to count by ones. I'm going to count by at least 2s. Let's see, 2, 4, 6, 8, 10, 12, 14. Nope, that's not going to do it. So I'm going to count by 4s. So -4, -8, -12, -16. So this is going to be my vertex. Okay, and the vertex is, sorry, I don't know why I put that in parentheses. That was kind of silly. The vertex is the point h comma k. That's either the maximum or the minimum. So in this case, it's 1 comma -16. Okay, and then the y-intercept, that's the place where x equals 0. So if I substitute 0 into my equation, 0 plus 3 times 0 minus 5, I'm going to get -15. So 0 comma -15. So it's going to be like right here, okay? And so that means there's probably going to be a point, mirroring it on the other side. And so when I put all of that information together, I end up with some type of parabola that points up here. And we really should always graph all the way through our plane. So let me just keep that going all the way through the plane. Okay, so based on everything that I just showed you, I want you to try graphing this second polynomial completely, okay? Now, if there's some funky numbers or something like that, just roll with it. Do this without your calculator, all right? Pause the video and then come back to compare your answers with mine. All right, welcome back. So let's see what we've got. I'm going to start once again with the fact that we have factored form. So that means I'm going to have an x-intercept at -2 and an x-intercept at 1. So -2 and 1. So that means my axis of symmetry is going to be at a half. because that's halfway in between. And based on the fact that this is a positive, by the way, like a positive one right here, I'm still going to have like an upward facing parabola, just like the previous problem. So the maximum is going to be somewhere below. So I need to substitute in 1/2. So I'm going to get 1/2 plus 2 and 1/2 minus 1. Okay, so 2.5 is 5/2. And that's -1/2. So it looks like I'm going to get -5/4. So that's going to be y equals -5/4, and my vertex is going to be at 1/2 comma -5/4. Yeah, if I didn't mention it before, the axis of symmetry and the maximum or minimum value, kind of put those two things together, because really this is at x equals h, and this is at y equals k. And the vertex is h comma k. So that point is going to be at -1/2, and then -5/4 is like just a little bit smaller than -1. Okay, and so then the Sorry guys for that awkward pause. I just realized something was not right about our graph and I was trying to figure it out. So I accidentally substituted in +1/2, but what I meant to substitute in was -1/2. Whew. So this happens, all right? You're in the middle of your work and you plug in maybe the positive value or the negative value. And then you can't quite reconcile, and I see students sometimes get like all in a flurry. But I want to just remind you that everything should always check out. So here's how I knew something was wrong. I know that the y-intercept is at 0, -2, because it's going to be at 2 times -1. And if you already caught my mistake, great job, seriously. But what I noticed when I was about to go finish graphing this quadratic was that the y-intercept was going to be here, and it can't be lower than the minimum. Okay, so that's how I knew something was off in my math here. So the parabola, like things that happen, should always like fit together. So if some part of your parabola doesn't look like it's going to end up being continuous or smooth or make that proper U shape, then just double check your math. There's no reason why we can't just go back and make a little edit. So here's the edit that I have to make. This right here is actually going to be -1/2 plus 2. So it's going to be -3/2. And this number right here is actually going to be -3/2. So then my k value is actually going to be, I'm sorry, this number is positive, -9/2. Which is about 2.25, but in the negative direction. Okay, so that point should be just a little bit below that y-intercept. Okay, and then we have a symmetric point on the other side. So this is at -9/2. And so then this guy, I'm sorry guys, I don't know where my head is at now. Just got all jumbled up. 9/4. We're sorting it out. It's fine. Mistakes happen. No big deal. But we got it all sorted out. Okay. So to recap, our vertex is at -1/2, -9/4. So it's a little bit lower than 2. Our y-intercept is at -2. And now we can connect all those points to make ourselves a parabola. All right. If you want to find more points, great. But really 3 points is good enough. Okay, let's move on to a couple of other things. So what happens when you get a parabola in a different form? Okay, well, there are 2 other forms. This form that we're looking at up here is called vertex form. Now, vertex form, as its name suggests, has a leading term a at times. In this problem, it's just 1. That can scale your graph like a vertical dilation. And then it's x minus h squared plus k. Remember that h and k I was talking about earlier? those are related to your vertex. Now keep in mind, you're going to take the opposite when you actually write your vertex. So I'm going to take positive 2 and make it negative 2 because that is the actual h value, because really this is x minus negative 2 in the parentheses. Okay, so that lets me know where my vertex is located, negative 2, negative 1. My axis of symmetry then comes directly from that value of h in my vertex. And then because this has a leading value, so if a is positive, you're going to have an upward facing parabola. So that means I'm going to have a minimum at y equals negative 1. So that means this parabola is going to point up. Now, the y-intercept still found when x is 0. But I'm going to have to do a little bit more work here. So 0 plus 2 squared, then subtract 1. So that's 4 minus 1. So that's 3. 1, 2, 3. Now, whenever you're writing a parabola, you are totally allowed to take a point that you find and mirror it across the axis of symmetry. Okay? And then the x-intercepts, in this problem, the way that I would find those is I would take the equation, set it equal to 0, so x plus 2 squared would equal 1. Take the square root of both sides, so x plus 2 would equal positive or negative 1. And then x would equal negative 2 plus or minus 1. So that's going to be negative 1 or negative 3. So negative 1, 0, negative 3, 0. Which it kind of looked like they were going to be right here, but it's nice to double check. Okay, so now I can connect those points. And ta-da, I have a parabola that I started with a different form. Okay, so I'd like you to try graphing this last one, number 4. See how much you can do, and we will definitely go over it in a moment. All right, welcome back. So, a couple of things. Again, we're in vertex form. This value we're going to take the opposite of, so 1, 3, 1, 3. Axis of symmetry still at the h value. Now, y is going to equal 3. But because this number is negative, that's an a value is a negative value, that means our parabola is going to point down. So that means we're looking at a maximum. All right. Now, to figure out the rest of this, let's keep rolling. We know that our y-intercept is when we substitute in 0 for x. So that means we're going to get negative 3 times 1 plus 3. That means we get 0. So that means our y-intercept is actually at the origin. And I'll explain why that makes sense in a moment. And if you look at that, that means we also, because I mirrored that point over, we also just found our x-intercepts. That worked out really nicely. Okay, but I'm going to show you why that works the way it does, like why that point happens to land right there. So a is negative 3. Now keep in mind that the parent, y equals x squared. If you're at negative, I'm going to do 2 in a second. If you're at 0, 0, you're at the vertex, okay? When you move 1 unit away in either direction, normally you would move up 1. But instead, because the a value was negative 3, we are negative 3 units away from the vertex. So, same idea here. The next point would technically be negative 12 units away. But we don't quite have enough space for that, I don't think. 3, 6, 9, 10. It's going to be somewhere around, so this is 3, 6, 9, 10, 11, 12. It's going to be somewhere around here. Now, because we are like off the grid, you do not necessarily have to draw that out. But I just wanted to show you that you can use your knowledge of transformations, your dilations, in order to help you understand why the shape looks like that and why the spacing is the way it is between your parabola. If you look at the other graphs that we made, the spacing here is, 1 unit and then 4 units from the vertex, because the first point squared is 1, the second point away squared is 4, etc., etc. All right, Hope you feel like you have some understanding of those features and that vocab. Thanks for listening, folks.